creating the database with Ensure created. In this tutorial, we shall move to the next step of creating our database, and we shall also create a table inside it, everything using the EF Core Entity Framework Core .NET code. We shall start by adding a model class. In simple language, a model class represents a record of a table. By convention, all models are placed in a folder called models. So create a folder called models like this directly inside your project. Add a class called product to the models folder. Right click here, add new item, type the name for your class and add the class called product to the models folder. This class is going to be our model. The properties of the model class, they together represent a record of a database table. This is the class that we have added. We have kept it very simple with just two properties, this property and this property. Entity Framework Core requires that a model should have a primary key. We have set the ID property as our primary key. Public int ID get set. We have set this property as our primary key. One primary key is must in a model class. This attribute database generated database generation option dot identity, it tells the Entity Framework Core that this key is an auto-incrementing primary key. When a new record is added, it will automatically increment by 1, so it is going to serve as our auto-increment primary key. Be careful to use this using directive. This using statement is required just at the top of this file. It is not visible here using system.componentModel.dataAnnotations.schema. This should be added just near the top of this file because this and this, they depend on this namespace. Use database generated option as none. We used it as identity. Use it as none if you want it to be a primary key without auto increment. Use none if you do not want it to be auto incremented. In that case, it will be your responsibility to ensure that this is a unique record. This is a unique primary key of your database. For example, you might choose an email to be your primary key. This annotation can in fact be skipped also, because Entity Framework Core has the ability to guess a primary key. If a property ends in ID, like course ID, then Entity Framework Core is smart enough to guess that key as your primary key. But I would suggest that it is better to use this annotation to mark the primary key yourself without depending on the Entity Framework Core guessing it. This is the only other property that we have added to this class to keep the things very simple. Now let us understand what is a DB context. DB context is the central class for your communication with your database. This is your database and this is your .NET DB context. Your project communicates with your database through the DB context, and this is the central class for your communication with your database. All to and fro traffic from your database takes place through this class. We will see how it works in our future lectures. We will in fact see it all at work, but right now I would say that dbContext is a sort of your database class that is parallel to your actual database. This is on the C# side. All communication to the database and back from the database takes place through a dbContext class. You can think of dbContext as the .NET counterpart of the physical database at the other end. This is the .NET counterpart of this database. Now, your project must therefore contain a class that inherits from the ready-made dbContext. For example, we have called a class public class project context. This project context represents your database counterpart, I would say, and this context inherits from the dbContext, and this class has to be present in your project for a to and fro communication with your database. Only one such class is required for your database connectivity. Only one such class per database is required for your database connectivity. Usually we have one database only, so one project will require only one class. So let us add a project context to our project. What we have done is public class project context dbContext. We have written this class inside the product.cs class only. You will see that we made a small space and typed this class here. Let us discuss the various parts of this implementation. First of all, this using statement. This must be added at the top of this file. Then we see there is an empty constructor. Public project context. This is the constructor. It takes an argument dbContext options. This project context specialization is for this only, and options, and they are passed to the base class. They are passed to the dbContext. So this is what you should do. This empty context, this empty constructor is required, is compulsory. Even though it is empty, this is a compulsory requirement. It is used internally by ASP.NET Core. So you have to supply this. Then you should override the onModelCreating method. Protected override void onModelCreating, and the purpose of this is that it will help you give a name to your table. Model builder dot entity product dot to table. This will create a table called product inside your database. This method gives you an opportunity to change the name of your table also. But my suggestion is that you should always add this, because the names of the table are many times required when you run direct SQL queries. Sometimes direct SQL queries are also required to be run. In that case, these names, they come quite handy. So you should always explicitly name them, like I have done. Then we have a plural dbSet property. This plural, product, products, this plural. Then plural dbSet property must be added. This property must be added for every model in your project. If I have a model called product, I will write public dbSet product products. If I have another model called course, then I would have added public dbSet course, courses, getSet. For every table in your database, you should add a plural property for dbSet. This is also required. This is actually a collection. This is actually a collection that is a temporary cache. This is a temporary cache of records that move into and out of your database. Suppose you want to add an item to your database. Your item will enter this collection. From here, it will move to the database when you save it. It keeps a track of changed records, dirty records, and all that. So what I would say is that this is a temporary collection that you must always add. This is always required. We will be using this collection 99% of the time. This is a very important property. This constructor, this override, and this property for each model, they are required. Let us next see the product.cs file that we have written so far. This is in fact the product.cs file. I will show you it now complete. These are the usings that are required. This is your product model, and this is the context that I have added just after that. Next let us go to the startup class and make a few modifications. Come to the startup class, the startup.cs file, and open it. Double click and open it. We have to, now this is the class startup. Inside this there is a method configure services. We have to configure SQLite as a database in this method. We have to configure SQLite as a database in this method. This is the first thing we are going to do. Add a DB context to the services container. See, services dot add DB context, the project context. This options goes to options dot use SQLite. This is the connection string. So we are adding our project context to the services container. Services dot add DB context, project context. This is options. It tells us that we are going to use SQLite with this connection string. This statement tells the ASP.NET Core to create a new scoped database connection on demand. This is actually dependency injection. It tells ASP.NET Core that this project context should be created on demand. The connection will be a scoped connection. Why I am saying scoped? Because the default parameter for this method, it accepts a scoped connection. The database connection is closed automatically by ASP.NET Core when the scope will end. So opening is on your request and closing is automatically done by ASP.NET Core when the scope ends. A scope starts when a user requests your page and ends when the page is served. So when your user has requested your page, a scope will start, and then you ask for this connection. This context will be created for you. When the record is served back, when the page is served back, this connection will be automatically closed for you. So this is a very good thing, and it will prevent the idling of database connections. So this is a very good thing that is available to us. We do not have to create this project context ourselves. So it is left to the ASP.NET Core to always create a project context for us on demand. Let us now try to open a connection for this. We will open that connection to create a database for us. But that is not the way you will always do. That is just a temporary way of creating a database. Let me show you that also. So next let us come to the configure method to create the database if it is not already created. So I am now showing you how to obtain your project context from this container and just for creating a new database. But remember, that is not the way you will always do. For every time you need a connection, the method I am going to show is not used. It is used only the first time when we want to create a database. For other times, there is another method. We will take that later. So, this is the code that we have added to the configure method. So just use developer exception page. So if you scroll a bit, this is the configure method that I was showing in the previous slide. Create a scope. We have to create a scope, and the scope is created this way: application services.create scope. This scope starts here, closes here. But when you use a page servicing, then the scope automatically starts when the request is coming from your customer. When you serve the page, the scope will automatically close. You will not need this. But we are now requiring this to create our database. So let us see how this is being done. Create a scope like this. Then obtain your context. Get required service. We obtain our project context. And ensure that the database is created. This method ensures that the database is created for you. If you run the application, then this hoven.db that we specified in the connection string. See, connection string hoven.db, then hoven.db will get created because that code, the code that we wrote just now, that will run and create your database, ensure created. If your database already exists, then this method will do nothing. So we have added it at that place so that if database is not there, then it can get created. Once you run your code into production, then you can remove that part. And when you open the Solution Explorer, you can verify that the file is actually created for you. The same code will create an Oracle database, SQL Server database, and so on. Thank you for now. We will in our next lecture take our further steps into our database connectivity. Thank you.